start recording. Okay, we're good to go. Alright, let's start this side.
Sure. Hey guys, we're gonna get started now. Hope everyone's having a good Wednesday. Today we'll be covering MVC, navigation, and also delegation. So these are all pretty important concepts, and I think they'll be a little difficult at first to kind of grasp, but I think over time it'll definitely make more sense. So first, let's get started with some announcements. So firstly, A1 is due tonight, but you do have a total of 4 free slip days. So you can use these slip days across basically the entirety of the course. So you can use 4 for A1 completely, or you can split these up over the next few assignments. If you're experiencing any issues with Xcode, GitHub, or if you enrolled in this class late, please come up to us after lecture or email us and let us know, and we can always give you extensions to kind of accommodate that. In addition, I guess importantly, there is a feedback/assignment survey. It's worth 1 free point of your assignment grade. So please fill that out. You can be brutally honest. We just want to hear your thoughts on lecture, assignments, and just like what we can improve on for future lectures. And also A2 has been released and is due Tuesday, March 26th. So that's a week from yesterday. But same rules apply. You also have 4 free slip days, and this one will be on GitHub. So when you submit, we will ask you to submit a TXT file with your GitHub repository link. Is that any questions about that? Okay, cool. So quick recap. On Monday, we essentially went through a view controller. We based on that little, blackboard, went through and drew out how we would constrain a view and also modify these properties, right? We changed, for example, the color of the screen to blue. We set the text for these labels, and essentially, I guess I'll go really quickly how to create and configure a view. You first create the view. So in this case, we're creating this UI label object. If you remember last time, we talked a bit about classes, and essentially we created a UI label object with this class, initialized and configured the view, and view did load. So essentially this was, you can change its color, you can change its text, and basically you can change a bunch of different properties about these views, and you basically afterwards you constrain these views in using NS layout. So that'll make a little more sense once we get a refresher later. So I'm gonna let Richie talk a bit about what we're gonna be covering today.
Yep. So today we're going to go over the model view controller and a little bit more details on how we implement this sort of structure in Swift. So in last lecture, we showed you how to create views with like hard-coded data. So for example, you guys remember the demo where we had a label with a name and as well as an image. So that was hard-coded, directly written into the code. However, a lot of applications are more complex than that. So oftentimes we want to edit that data. We want to update our views according to like something we fetch from a backend API, things like that. So, when it comes to that kind of thing, we can't really hard code values like that because it's constantly changing, and thus we have to constantly update our views accordingly to the data. So this is where model view controller comes in. So we're going to start with a quick definition here from someone I don't know, I forgot who. But MVC is a software design pattern, which is a set of rules that govern the architecture that we follow when writing our code. In other words, it's not really a physical thing, more so a concept that we follow throughout development that allow us to organize our code so that we can most ideally update our data update our views according to our data that we receive. Okay, so yeah, MVC stands for model view controller, and the first of which means model. So the models are the objects that represent our application's data. So they're the main information in our app. They contain information about our applications, and they're often updated based on user interaction or from a backend API. So, for example, some of the models you might encounter in Eatery would be the dining halls, the dishes, food items, as well as the user information. In an app like Uplift, it might be the gyms, gym hours, things like that. So those are our data, and models are what we use to represent them. So typically, when we're using models, in Swift specifically, we use structs when we're defining data models. So you may be asking, what is a struct? So in the other lecture, we went over sort of what classes are, and classes and structs are sort of hand in hand in that regard. So structs are value types and classes are reference types. So essentially they can both be used to represent data. However, structs tend to be more simple and what we most often use when we're creating models. So main difference between, I guess, classes and structs that you need to know for this class is that classes support inheritance, so subclassing, things like that, whereas structs actually don't. They're just a lot more simpler, and you actually don't need to define an initializer for structs. So just because of that simplicity and that they're value types, we like to use those for our models. So beyond the scope of that course, we don't really need too much. If you guys do want more information about more minute differences between classes and structs, there is a chapter on the textbook that you can refer to. Okay, moving on. So in addition to our models, we also have the views. So this is what you're actually physically seeing on the app. They are the visible components that are used to build the user interface, or the UI. So this includes buttons, labels, images, etc., any sort of thing that you see on the screen that consists of the view. So I guess using Eatery as an example again, that would be, the dining hall would, have a UI label for the name, a UI image for the image of the dining hall, potentially like a table view to represent all the menu items, things like that. So those would be your view, things that you're actually seeing on the screen. Okay. And then last but not least, we have the controller. So the controller is the thing that sort of ties everything together. So it establishes the connection between the models and the views. So keep in mind, the model and the view directly do not interfere with each other. The model cannot contribute anything to the view, and the view cannot communicate directly with the model. So this is where the controller gets in. So if you guys remember from last lecture, we sort of was working on something called a view controller. So this is what that was. A view controller is a controller, so in UI Kit, we use a UI view controller to communicate between views like a UI button with changes in the model. So clicking a button can change another view or change the data. So that's where sort of the controller comes in. It's sort of harder to visualize compared to the model and the view, but you can think of it as sort of like the communicator between the model and the view that allow us to make that full interaction of update view, data, things like that. Okay, and just getting it all together, you can sort of think of MVC as watching television. So you can think of the actual TV as the view, the remote controller as the controller, and you can think of the channel and the content as the model. So how does the TV or the view change the model? It can't, right? You can't really change the physical channel content from the remote. You use the controller to do that, right? So you use the controller to communicate between the channels and the view that you're displaying. So when you're changing channels with a remote, it's the same as using the controller to tell the model. So using the controller to update the view with the model. So that's sort of how that communication works with MVC. Okay, so we're gonna go to Tiffany to tell you about a little bit more about navigation and navigating between views.
Okay, so now that we've kind of spoken a little bit about this MVC and the architecture, hopefully you guys understand a little bit more about, I guess, the complexity of an iOS app. It needs to have all these different features. And you imagine, if you have multiple screens in an app, it becomes really, really complicated. So I guess a part of this complexity is definitely having multiple screens. And you might be thinking, from last demo, oh, we only made basically one screen. That might be a little boring, right? So I guess we'll cover this time a little bit about how to navigate between screens and different view controllers. So each screen, as demonstrated from last demo, is represented by a UI view controller. So if you want to make the home page, that would be a home view controller. If you want to make a secondary page, you would have to make a whole different secondary view controller. So far, we've only worked with one screen containing many views. But today we're going to create multiple screens and show you guys how to navigate between them. So I guess why we need to learn how to do this is because if you imagine for an app, we don't want to jam every feature in the world in one screen. That doesn't really make sense, right? We wanted the user to be able to intuitively navigate between screens. So let's talk about how we can implement some navigation to allow users to kind of navigate between screens that we define. So there's two main ways: pushing/popping. So this is the first way, and presenting/dismissing is the second way. So I don't think those make sense without AJET. So the first, I guess really quickly, the bulk of the demo will be about pushing and popping a screen, and I'll cover really quickly what presenting and dismissing looks like just for your guys' understanding. So really quickly, this is the, gesture for presenting and dismissing. So when it comes up, it's being presented, and when it fades out, when you swipe down, it's being dismissed. Does that kind of make sense? So alternatively to that, we have pushing and popping. So the way that this kind of works is via a navigation stack. So if you notice, when I click on, I'll go back. when I click on an album, it kind of pushes on top of the previous screen. And then when I click on my name again, it pushes on top of that. So the way I like to think about this is that, fancy. So if you guys have heard of the I guess terminology of a stack before, so let's imagine this is like our the bottom of our stack. And if you've heard in other CS classes before, like how a stack works is that you're basically putting things on top of each other, right? So the way the navigation stack works, you can imagine this as like the very bottom of your app, and when you push a new view, it gets pushed, I guess, you can imagine this as like a view, I guess. This gets pushed onto the top of the stack. So this is now the view that you see. So let's say this is like your home page. And then what we'll essentially implement is the functionality of, let's say when I click on a playlist, I'm pushing something else on top of this existing stack. Does that kind of make sense? So for example, when I push this playlist view on top, now what I see, if I'm looking for, I guess, from top down, this is the view I see because this is kind of covering the home page. So that's essentially, like, it's basically I'm stacking on top of each view. Yep. Any questions on that? Okay. So this is usually created inside of the scene delegate, so I can show you guys quickly later what that looks like. And that essentially that stack structure is represented with a what we call a UI navigation controller. So let's go through the demo real quick on how that looks. So firstly, the demo code is always on here. If you guys are having trouble cloning this, if you guys are having trouble cloning this, I also attached a zip file down here. So you can just hit this and it'll download the zip. So if you don't have GitHub working, I guess, for this lecture, feel free to just use this for now. But do come to us after class to get, I guess, that issue resolved for A2. So let me clone this. Is this your desktop?
Yeah, you have to see that.
Oh, did you just
SSH.
I think you made it ready.
It's already made.
Yeah.
Oh wait, make sure it's not the full one.
Oh, you're right.
Git reset. CD into it. Yeah, I think it's.
It's a blue one. Oh, I see it too. Yeah.
Change the branch too. So git reset. Right here.
Wait.
Yeah.
Is anyone having trouble cloning the repository? Does anyone have the demo on your laptops?
Yeah, should be.
Okay. Cool. Thank you. So you'll notice that for this project, there's quite a few more files, and they all have, like, I guess, pretty important stuff in them. Let me make this a little bigger. So if you notice, we have now a controllers folder. So essentially, this folder is, I guess, conventionally used to store all your view controllers. So in this, we have, I guess conventionally you would use better names, but we have view controller 1 and view controller 2. Right, and we also have a scene delegate. So really quickly, before I mentioned that we define our navigation stack in this scene delegate. So if you notice, this is essentially what gets run when your app first opens, and we create this window and we create this root VC. So this is what we want. We're basically telling the app that we want this to be the first controller that shows. Right, so I guess in last demo, this was already pre-set up for you guys, but when you make a project from scratch, you will have to go through like this whole setup as well. And as you can see here, I also defined a nav controller here using the UI navigation controller class, and we passed in this root VC to designate it as like the bottommost view controller of the stack. Does that make sense? Okay. And then we just set it to be, you set the window and you just call make key invisible. And essentially, we don't have to go into much detail, but this basically just makes the screen show. So more importantly, if we go to view controller 1, if I run the application right now, you'll see that nothing actually happens when we push this button. So we have a button here, a push VC button, a text label. Do you guys kind of remember what this looks like from last demo? I'm Let me run this. So we're basically defining two views, right? We have this first button view and this UI label view. And in these functions, title, we give it a color, we give it a background color, etc., and then we constrain it. So when we run this function in the view did load, oh, wait, it's lagging. When we run this right here, this whole thing runs, and it configures the function, configures the button to appear on the screen. Any questions? Okay, let me pull the simulator. A second, and then similarly with the text label, you also have the same type of setup. You give it text, you give it a text color, you add it to the subview, and then you constrain it to make it appear on the screen. And the chunk of what we're gonna do here is with this function. So if this wants to open, I can show you guys. So we have these two, we have this first one and we have the second one, right? And the point of today's, I guess, demo is to show you guys how to make, how to make this button in the first one push the second one on top. I guess, like in this case, right now we only have, view controller 1, right? So this is our root view. This is the only thing we have on the stack right now. And what we're going to do today is show you guys how to push the second view on top. So, load. Okay, there you go. So we're going to try to, if you notice, if I try to hit this button right now, nothing's happening. And if you notice in this line, so line 39, we set this target for our button, and this function that we pass into this argument is the function that gets called when we hit this button. But notice that when I click on this and I click jump to definition, it's currently empty. And what we want to do here is essentially perform that pushing motion where we push that new view on top. So we're gonna first initialize and I guess instantiate this second view controller by creating it with controller 2. So what's happening here is that I'm basically creating a view controller 2 object. So this is creating that second view, and we want to tell the navigation controller, so it's optional because it might not exist, and then you just call push view controller on this navigation controller. So we're telling it to push this new view on top. So you can imagine I want to pass in this controller that I just defined, so view controller 2, and animated I'll just pass in as true. And now we run this. Yeah, sure. Is that big enough? I can also go big. Is that good? Okay. Why is it paused? I set a big point. Oh, there we go. Oh, also I guess this is a perfect example because I always misclick here. I noticed I had a few ed posts asking about like breakpoints in A1. Sometimes you might accidentally make a mistake like this and set a bunch of breakpoints. And essentially what a breakpoint does, you'll notice that your code will stop running at exactly where the breakpoint is set. So in this case, the code runs all the way up to here and it stops. And that's because it's useful for debugging. You can imagine if you're trying to debug where your code is going wrong, you might want to set a bunch of breakpoints. It's kind of equivalent to like writing a bunch of print statements. But in this case, to get rid of them, you can just swipe right on them. Oh, and that'll get rid of them. And then you just hit this, and it continues running. So now if you notice, if I hit this button, it pushes view controller 2 on top. Does that make sense? Okay. So now that we have this new view controller on top, you might be wondering, like, how do I get rid of this? Like, I don't always want this to be on top. Let's say I make an edit and I'm like, okay, I want to go back to the main view. If I try to hit this pop VC button that we defined in view controller 2, you'll notice that there's also nothing defined here. So essentially this button is like useless right now. So we want to define a function that essentially pops that second view controller off. So now we're in this state, right? So now essentially what we want to do is get rid of this. We want to pop it off the stack so that the only thing we see is our original view controller. So it's only one line. So really quickly, navigation controller and you just call pop view controller, and you pass in true as animated, and that should. Any questions? Yeah, what's up?
Why is navigation controller optional?
I think the reason why it's an optional here is in the case that like it doesn't exist. I think if you don't have this, it'll like and you try to run this function, it'll just crash the whole program instead of it being it not doing anything. So I think generally you always wanted to like not break the whole app versus like, you know, if you just spam a button and nothing happens.
And it should be automatically optional. So it's an optional integrated within the UI view controller class. So it's already an optional, so therefore you have to sort of unwrap it by saying that this is an optional and this may not run each time. I think the biggest reason why is like if you're say presenting a view, it may not have a navigation stack because you're presenting it on top rather than pushing the view. But presenting, we're not really going to cover in this lecture, but that would be a scenario where you wouldn't necessarily have a navigation controller.
Cool. So now that we've implemented pop VC, if we run push VC, so that runs and pushes it on top of the stack. Now if we run pop VC again, it gets rid of it and pops it off the stack. Yeah, cool. So I'll pass it back to Richie for some delegation.
Okay, sounds good. Okay, so yeah, now I guess it's like before we hop into delegation, just a big disclaimer. A lot of students struggle with this topic and understanding like, you know, just how delegation works. So if you do have any questions, please feel free to ask, you know, raise your hand, ask the question, or just ask on EdSTEM after class. But okay, let's just get started. So now that we have like multiple views created and we can navigate between them, we now want to learn how to pass information between them. So, you know, how do these separate view controllers actually communicate and share information with each other? So it's actually pretty simple to pass information from the parent view, so the view on the bottom stack as Tiffany drew, to the child view, which is on top. So I guess just to get familiar with terminology, the parent view is the view that pushes the child view. So child view is pushed on top of the parent view, and you can essentially treat it as like whatever view came first was the parent view. So yeah, so you know, delegating, so what is it? Passing information from the parent view to the child view is a lot easier, but when it comes to the situation where you're trying to pass information from the child view to the parent view, that sort of requires a little bit more work, which is where delegation comes in. Okay, so yeah, delegation is the process that allows a child VC to communicate with its parents, and typically we use a protocol to do this. We will cover that a little bit later. Just and more terminology you should be familiar with. The delegator is the VC that is delegating the task. It is often the child VC telling the parent VC to do something. So the delegator is the view controller that asks the other to do something, whereas the delegate is the VC that is being asked to do something. So in this case, it would be the parent VC that the child view controller is asking for it to do something. So again, delegator is asking the delegate to do a task. And the common language that they do it through is the protocol. Okay, so protocols are a set of properties and methods that classes must implement when they're conforming to it. So, you know, if you've ever taken Java or used Java, it's similar to interfaces. It doesn't necessarily have the implementation, but it sort of has function stubs or property stubs as well. So we typically create extensions of our classes to make, you know, the code more neat. You could sort of add it as a subclass when you're, you know, conforming to a protocol, but typically we can use extensions, and we can show that later in our demo. Okay, so here is sort of an example of how we would use a protocol. So we have our parent view, and we want it to extend the protocol, which is the update text delegate. So the protocol is called update text delegate, and this is the common form of communication that we use between the child and the parent view. So the parent view is being asked to update their text, and the child view is the delegator that is asking the delegate to change that task. So yeah, again, the child view in this case is the delegator. It's asking the parent view, which is the delegate, to perform a task. So, you know, all this terminology using the word delegate and delegator may be a little bit confusing and kind of a tongue twister at times. So I can give you like a simple analogy that I like using when, you know, talking about protocols and just delegation in general. Go over here. Okay. Okay, I guess like you guys can imagine a situation. So let's say you guys are in a bar and we have, let's say, a customer sitting here, and we have, let's say, a bartender or a waiter. So let's face here. It's the waiter. And then, you know, we also have a menu. So the menu, like, you know, of the drinks or food or whatever the customer wants to order. So you have customer, or you have a waiter, or a bartender. So you can think of the customer as the delegator in this case. In this case, the customer is asking the waiter or the bartender to make a drink. And in this case, the bartender is the delegate because the customer is telling the delegate or the bartender to do something for them. So in this case, you can assign the delegator to the actual customer, and the delegate could assign to the waiter. And this common knowledge, the common language that you're using to order this food or whatever task you're asking of the delegate, the common language that is shared is the protocol. So without the protocol, you can't exactly communicate. So that's like, you can imagine like menu items, things like that. That is the common language that you share between the delegator and the delegate. It allows the delegator to ask the delegate to perform tasks. So this is sort of the protocol. You can think of it as the menu is the protocol. Yeah. Okay, so that was like a quick sort of analogy that you can use to describe protocols. So we're going to move on to sort of a demo from, adding on to Tiffany's code before on how we can actually implement delegation. Okay. Let's see. Okay, so I guess first of all, you can sort of see that when you push this VC, we have this text field right here. I think my keyboard is not use hardware. Okay, so as you can see here, we have the text field here, and then when we click pop VC, we actually want it to change the text here. And you can also see that it says change me here, but when you push it here, it still says placeholder. So we want to sort of establish that communication between the child and the parent, and then we can use delegation and something else for that. So first we're going to do the easier part, which is communicating between the parent and the child. So in this case, you can see that view controller 1 is the parent, and view controller 2 is the child, because view controller 1 is pushing on view controller 2. So in this case, what we actually want to do is we can directly pass information from view controller 1 into view controller 2 through the constructor here. So you can see that our parent view controller, which is 1, is directly calling the constructor, which is view controller 2. So using that, we can actually pass in information by using the constructor of view controller 2. So let's say we actually wanted to define an initializer. So we can do init. And let's say we wanted to do add the text, which is some string that we want to modify on the child view controller. So I'm going to do self.text is equal to text. Also, in this case, since we're using self, we actually do want to define a new property because we want to save the text from the parent class into the child class. In this case, we want to always label our data. We can do private, set a variable, text, and have it as a string. And in this case, in our initializer, we're initializing that text to the text that we're passing in the parameters. And you can see that we're also getting this error here. So whenever we're sort of creating an initializer, there's always this required initializer that Xcode wants you to do. So all you can do is just simply click on the error and click fix, and then that'll fix your problem for you. It's very simple there. And then another thing we need to do, so if you remember from last lecture, since we are creating a subclass of UI view controller, we do need to call the super initializer of view controller. So what we can do here is called super.init, and you can see that autofills, and then you have something called nib name and bundle. You guys don't have to worry about what these are specifically within the scope of this course, but for now you can simply just put nil within these values, or just a none value if that's what nil is. So yeah, so once we have that, we'll actually get an error in our view controller 1 because we have a new updated initializer. So again, you can fix that. We can fix it manually, or you can directly just type it in. And in this case, we want to pass in the text here, which is change me, right? So you can see on the first view, we have the text change me, which is also represented here in the string in the property data. Okay, so we can do text, and there we go. So once we do that, we actually need to change one more thing, I'm realizing, is because right now we have this set as a hard-coded value called placeholder. So what we want to actually do is use our property that we newly defined up here, which is text. So we could change the placeholder here to text. And now, as you can see, once we rerun that data, we'll be able to pass information from the parent view controller to the child. So yeah, as you can see, it's a lot more intuitive in this regard because you're directly passing information from the parent directly to the child. So as you can see, rather than saying placeholder, this now says change me because you're passing that text from the parent view controller to the child. Okay, so now we're going to go into the hard part, which is delegating between the child and the parent. Because as you can see in the child, view controller 2, you don't really have any access or reference to view controller 1 because it's being pushed on. You don't really have any direct references to it. So this is where delegation comes in. So actually what we want to do first is let's define a protocol. And the protocol is the common language that you're communicating between the parent and the child. So you can do this anywhere really, but I like doing it here since it's a lot easier. We're going to use the keyword protocol to define a protocol, and we want to call it something like update text delegate. Since this is what the delegate is doing, the delegate is for updating the text. And it has to be of type of any object, which just means any. In this case, we have to establish a type, otherwise Swift won't let us create a reference to it. And in this case, we actually want a function that we can use to update the text on the parent class, on the parent view controller, sorry. So we can call a function func, use that keyword, call it update text, and we want to take in a parameter that is the new text that we want to replace, and that has to be of type string. So as you can see, that's all you need, because the protocol is just sort of a specification that you want to implement something later on. So it is like it is like an interface in Java. So you only need to have the function name as well as the parameters that you need. So now that we have that, we actually want to create a reference to it in our child view controller. So you can think of this as the protocol is like the reference to the delegate. So, and keep in mind our view controller 2 is our delegator. So we want to have a reference to the original parent view controller on our child view controller. So in this case, we want to define a reference, and we want to use a weak reference here. And we'll go into more on what weak means later on, but for now, just make sure when you're dividing a delegate, use the keyword weak, there, delegate, and we want to make that of update text delegate. So that's the type of the protocol that we're using, and this is sort of treating it as a reference to the parent class. Okay, so now that we have that, okay, so yeah, since we do have that now, we have the delegate, we want to make sure we update our initializer so we can sort of pass in the delegate. So we can also pass in sort of the parent class through the initializer in this case. It seems kind of weird, but you're passing a reference to the parent class to the child class. So in this case, we want to add a new parameter called delegate, and we want to make it an update text delegate. We can do self.delegate is equal to delegate. So that allows us to pass in the parent directly into the child. So here, you can see that this will ask us to probably update that. It says missing argument for parameter delegate and call. So what we actually want to do here is directly just pass in the parent itself by using the self keyword. So you can see now we might run into an issue because sort of we don't know if this parent is a delegate. So you can pass any sort of self, but it doesn't necessarily conform to the delegate. So it's asking us that this view controller 1 is not conformed to update text delegate, which is the communication between parent and child. So in this case, it may ask us to sort of conform it by fixing it like so. But the thing is, it will just add sort of the type up here like so. And we don't want it to do that. Usually when it comes to delegation, we want to use an extension. So essentially what an extension does, you can just treat it sort of as like you're extending essentially the view controller. So use keyword extension, and you want to type the same name of the view controller you're extending, and then you want to use follow up by a colon for the update text delegate, which is what we're extending it to. So the nice thing about Xcode is, again, it'll realize that there is an error because this still does not conform because we do not have that one function we defined. So what we can do here is click that automatically to fix it, and I'll put in our function stub here, specifying like, oh, now you have to implement a version of update text that allows us to update the parent text. So what we can actually do here is we can update the text. So we can update self.text is equal to the new text. So this is, keep in mind, this is in the parent view controller. So this is the communication, and this is what we're specifying. This is the task we want to perform, which is updating the text to the new text. So keep in mind also, text is just a variable, but we also want to update the views as well. So what we actually want to do here is change for the properties of one of the views, and that would be the text label that displays the new text. So you can do self.textlabel.text and change that to the new text as well. So in this case, we're actually updating the data as well as the views once we push that delegate. Okay, so as you can see here, we try running now. We sort of have this established communication between the child and the parent views using this protocol. But you may see that it's still really not doing anything. Let's say we wanted to change. So whatever we type here, if we put push pop UC, it should actually change the text. But for some reason, it's still not updating. So I guess the main reason for that is because we haven't actually called the function that we defined here in our child VC. So we have this function called update text, but we haven't called it anywhere in our child VC. So what we want to do here now is, since we have access to the delegate, which is a reference to the parent class, we could directly use our delegate. And if you click dot, you'll actually see our function here, update text, is actually there. So we can do update text, and then we want to update it to whatever is in our text field that we're typing. So the text field we have is right here. It's called text field. It's defined up here. And we can actually access its properties as well. So we can access its properties by doing text field dot text. We may also get an error here because the text field of a text is always optional, because sometimes you can have nil in it. It can have no value at all. So what you want to do is actually put in an optional value here. So we can specify a default value of just an empty string. Okay, so now if we run it this time, hopefully when we write something in our child view controller, it'll update. Okay, so it says change me currently on our parent view. If we push the VC to get to the child view, let's type in something. Now if we pop the VC, you can see that now we have established this communication between our child and our parent view. And again, if we push it again, it'll see that it still shows up there. So you have this two-way communication between your parent and your child view, to where communicating between the parent and the child, you just directly pass it in through the constructor. And when you're communicating from the child to the parent, you have to use this delegation structure to actually pass the information through. Okay, I know that was a lot. Does anyone have any questions about how all of that worked or anything like that? Okay, if you have any questions later on, feel free to ask on Ed. We'll make sure to answer those. But yeah, that's sort of it for lecture. Anything you want to add?
Wait, I feel like that was like kind of. Wait, maybe I should go over like the whole flow really quickly.
For delegation?
Yeah.
Yeah, sure.
Because I feel like that was a lot of code.
It was a lot of code.
But on a higher, I guess I'll go over it at a really high level. So when you hit this pop VC button, we're calling this pop VC function, right? And in this function, we're using the delegate. So notice that this delegate, if you jump to the definition, it's defined here, and we set it in our init function. So this delegate refers to viewController1. Does that make sense? Because viewController1 is what we want to be making the updates. So when we call delegate.update text, we're essentially calling this function in viewController1. So when we call this function, we set this text and we change the text label, and therefore, is it empty?
I think the text field is empty. You gotta click it. It's kind of hard to click.
Okay, but therefore, like, this string that is supposed to exist here changes. It's a little confusing at first, but I think it's something you can always ask us to re-explain, because like, personally for me, when this was like the hardest topic of the course to kind of wrap my mind around, so definitely feel free to ask. Like, yeah, what's up?
Does it matter? Does it matter whether the protocol is defined in viewController1 or viewController2?
I don't.
So actually that doesn't matter, because
Yeah.
you can, when you're creating files within the same project, all of them are shared unless you make them private. So you can see private let. That private sort of indicates that that can only be accessed by this class. Otherwise, if you don't specify, if you define that protocol anywhere within any file within the project, you can actually access it anywhere. So technically, it doesn't really matter wherever you define it, but I would, keep it either on the parent or the child just to keep things consistent.
Yeah, I think the only important part is that you make sure that the parent extends it, because you want the parent to be the delegate. Okay, cool. Any other questions? Yeah, what's up?
Do you like run the correct, or like once you pop and push a couple times, like the text part, like
Mm-hmm.
like erases and doesn't exist anymore? Is there a reason for that?
Didn't run those. No.
I think it's just that there's no placeholder text, so I don't think it shows up anything. But but I believe it's still there.
The-
Because like I think because you're sort of did you like push the VC without any text in the text field?
No, I updated, like, I put a text and then I like popped and like pushed and like I did it like a couple times back and forth and then
So
it erases.
we can run it maybe. Let's see.
Yeah, let's rerun that.
I've been there for too long.
Wait, so you're saying like once you pop and push a bunch of times, it just disappears? So you push and then pop?
Or yeah, we put some text into yeah.
Okay, so I think that's just because there's no placeholder there. Let me try.
Oh wait, it's because when you pass it back, it's nothing. So it's nil, so it defaults to empty string.
Yeah.
So then when you go back.
Wait, so you're saying if you put text here and then pop it again and then push it again?
It should only disappear if you're not putting any
Yeah,
text
if you're not
in
putting
it.
any text, it
Okay.
it replaces it with an empty string, so it looks like it's gone, but it's just kind of hard to click in because it's so small now. Because like the width of the text field is defined sort of by the placeholder if you don't put any constraints there. So if your placeholder is nothing, it'll disappear. We didn't constrain it well in this one, but
That makes sense.
usually if you would constrain it, you would actually set a width to it so it wouldn't disappear if you had no text. But in this case, it's because like you see, if we don't put any text and we pop it, it'll disappear,
Right,
and it'll disappear there. So yeah. Any other questions? Okay, sounds good. Let's move on to the Kahoot. Let me stop recording.